Dirty Scrap Podcast.
Hi Martin, how you doing?
Hey, good. And you?
I'm doing fine, and thank you for being here with us again on another episode of Dirty Scrap. And the idea of this podcast, as you already know, is to dig into the trends, the challenges, and everything that the aluminum recycling industry is facing, right? At least in the US, because the European countries are a little bit different right now. How you been?
Very good. Very busy. We see a lot of stuff going on, which is always good.
Right. Yeah, it's always good to be busy. And I think the idea of today podcast, first of all, thank you so much to being here with us for a second time. It's always a pleasure to having you here because all the knowledge and experience you have. So the idea of today episode is to go digging into the trends in the secondary aluminum cast houses. We just released a paper or article in one of the best magazines that I think we have into the industry, that is the Light Metal Age magazine. And we built this article with you and your daughter Alicia and myself. And the idea is to talk about the trends. And I want to see if we can dig into, let's say, all this history that you maybe has knowledge because you've been in the industry for a long time, and try to understand how the industry is growing and changing and approaching to this new, let's say, tools that we have right now, that like technology and processes and having more scrap. So before we go in that direction, I just want to refresh all the people that we will touch with this episode about your background. So if you can give us a little bit more about your background, how many years you've been in the industry, and everything that allowed us to know you a little bit more, please go ahead.
Oh dear. Yeah. Well, then that makes me feel old now, but okay. Yeah, I've been around in the industry now for almost 30 years, and actually on pretty much all sides of the value chain, and dealing a lot with castings, as you know, a lot with metals. Worked for 12 years at Alcan and Rio Tinto. So primary aluminum producer, worked a lot with from end users through basically the whole supply chain. And now, since many years, a lot with recyclers. The great thing in the past, recycling did not have a great name. Secondary was kind of, right. You want high quality, you want primary metal. And, we had that time when on a specification, you would limit recycling content. And, oh my God, we have a quality issue. Let's eliminate all recycling. Let's only use primary. And, luckily those times have changed completely. The whole trend with sustainability has brought recycling into a completely different light. Now recycling is great. Scrap is actually positive. We want to integrate, ideally even post-consumer scrap. Right. Even prices have inverted. I had just yesterday a call with a big end user, and they said, well, yeah, we want to use more recycled aluminum, but guess what? It's actually more expensive than using primary. So, hey, imagine that 10, 15, 20 years ago. So things have changed, and that's great. One completely different other thing is in the past, we had such a complete separation. We had the primary producers, right. And most of them were basically looking down at, the little secondary guys, and you had a lot of these little secondary guys, and they recycle scrap and make secondary alloys, and they had nothing to do with primary. And you had the big primary producers and totally different league. And, I don't know if you read this morning, EGA is acquiring 80% of Spectro, Rio Tinto bought 50% of Matalco. All these giants of primary producers are buying into secondary. And why are they doing that? Because, there is becoming, we are seeing this huge push for it. The OEMs, it's no longer, you can have maximum X% recycling content.
Right.
They have a minimum recycling content. And of that, they want a minimum post-consumer scrap in there. And they come with a carbon footprint calculation. And hey, we can do whatever we want with primary production, but I mean, it's still at least 4 times higher than if I use secondary to make a certain alloy. So even with hydropower, which cuts it down a lot. I mean, we know that coal-fired primary aluminum is 20 tons of CO2 per ton of aluminum, can be even more. Silicon is no better. But anyway, so if I use primary metal, I'm at a very high level. Global average, I think it's still like 16.7. European imports are better. European production is better. North American production is very good because most of it is produced in Quebec or British Columbia with hydropower. But even if I use this low carbon hydropower, well, I'm still at 4. Approximately 4 tons of CO2. And I mean, a lot depends on what input materials I use, because even alumina has a big variation depending on where it comes from, how it is made. So even these 4 can be sometimes a lot more, even though I have hydropower for the electrolysis. So to cut that down, I have to go into scrap. I just need to integrate scrap. So, and that's a great thing. We have seen so much going on in the scrap industry, and so much has changed. It has gotten a much better name. We have improved the technology so much. I mean, look at scrap sorting nowadays. I mean, has become so much better. We still have a long way to go. Also, I mean, you would normally think we are all working on closed loop systems. So a stamping house should never mix 5000 and 6000 series scrap. Well, if you buy sheet scrap, you might still end up with some steel sheet in there. You know, that should really never happen. So we need to get better in that, because we'll have to deal with the mixed scrap when it comes to end of life vehicles. Because, well, if I have a door that I can easily remove, well, the inner door panel is still a 5000, the outer is a 6000, so they're welded together. Separating them will be hard. 5000 high magnesium, 6000 silicon and some magnesium. Okay, what do I make out of this? How do I, because, well, we all know, so dilution is the solution to pollution. But if I have to dilute so far down, I can't meet the carbon footprint and recycling content targets anymore. So we're looking at, okay, how can I create alloys that will take all that mixed scrap? Or we have to look at technologies that can take something out.
Exactly. And how do you think that the industry is approaching to this transition? Because in several episodes, an episode that I did like a few weeks ago, I was saying, okay, everyone is talking about, oh yeah, we are going to net zero, we are lowering down our carbon footprint. But the issue that I am seeing here is we are comparing the secondary industry against the primary industry. But if we really want to focus on being in a better shape for the, let's say, CO2 emissions lower down, we need to compare what we have as the secondary industry today with the secondary industry of a few years ago. Because at the end, if we compare apples to apples, we will see the right difference, right? So I am seeing all this vertical integration between Rio Tinto, Matalco, Spectro right now, as you just said. How do you think this, because at the beginning, when I started this, I was thinking, oh, okay, what we are trying to do is to try to disappear the primary industry and just keep the secondary, but it's not going to be possible, right? It's impossible.
No. Well, in maybe 100 years or maybe 50 years, maybe. I don't know. But not now.
How are you seeing this transition, and why do you think these primary guys is right now merging with these secondary people in order? I understand why, but I want your approach. I want to see your perspective. What do you see right now is the transition approach, and why these guys are doing this?
Well, I mean, they're doing it because they have no other choice, ultimately. I mean, it makes business sense. So, and if you're pressured by your customers and you see, hey, well, I have to do something or I will just lose market share, you know? I mean, when you talk to some of the primary producers, I mean, you heard them say, hey, if we don't go down that path, we basically will produce sweetener, you know? We will produce for the secondary cast houses what they need to dilute, and everybody will buy from secondary cast houses because they can offer the necessary recycling content. So they have to do that. When you talk to some of the primary producers, I mean, of course, some in Europe, Hydro, for example, yes, they have been offering high recycling content from primary cast houses since quite a while. They have always been in that business. But I mean, if you look at, I live in Montreal, Quebec, so the Quebec smelters, the systems were designed to have a cast house to freeze the metal that comes from the pot line. They were not designed to take scrap. Plus, they are often far away. And I mean, look at where our smelters are. I mean, Iceland, far up Quebec, far up British Columbia, you know, they're not in places where you have a high density of population, where you have a lot of post-consumer scrap. So why would they design a cast house to take a lot of post-consumer scrap? So historically, it was just not that way.
Right.
So now they are stuck with cast houses that are not suitable to take that dirty scrap, and they don't have economical access, because bringing a lot of scrap for thousands of kilometers doesn't really make any economic or environmental sense either.
Right.
So I think for them, it was just natural to say, hey, then let's buy into someone who's closer to scrap and consumers and buy them. And I think the good thing is these primary producers have a lot of financial power. They have armadas of research people, so they can bring a lot of that to the table to really advance the whole recycling and secondary industry. And really this black and white from the past, oh, it's dirty secondary or clean primary, is becoming all one big gray area, the 50 shades of gray of aluminum,
right.
You know?
Right. Yeah, definitely. And how do you think this will improve, for example, the quality of the metal coming out of the secondary industry? Because as you just said at the beginning, let's say that the foundries, that is the people that is taking care of the raw material or the ingots, the cells, that are coming from the secondary industry to build a final product for the end consumer, they've been worried about, okay, quality of the aluminum, right? Do you think that improving the technology and sorting approaches, cleaning devices or systems will improve, of course, will improve the rate of the amount of scrap that we can use into the secondary industry, but also will improve the quality of the aluminum? Do you think also this merge between the primary guys and the secondary will help to do that?
I think so. That's why I'm saying, you know, the financial power and the armada of research people that we have now available to also work on this. I think that should help. I mean, we have, our secondary industry has come a really long way, the whole recycling industry. We've developed a lot of things with the vision system, with lip system, identifying scrap. And if you look at modern systems that can just blow out in different directions, different types of alloys, it's great. But I mean, we're still far away. We say, oh yeah, with lips, I can detect exactly the alloy. Well, I can detect the type of alloy. I mean, we're still far away from precisely pinpointing the exact composition. I don't have the time in a scrap stream. I don't have the time. If I have a huge bath of whatever, 20, 50, 100 tons, and I use my spectrometer analysis, it takes me a few minutes, but then I have the precise composition of that whole bath. Here I have a conveyor belt with a ton of different alloys coming my way, and I would only have a fraction of a second to analyze every single part and then put it into a different direction. That's right now still impossible to do. So we still have a long way to go there, and then also to develop ways to cope with the impurities that we can't get out. And I mean, I see a lot of R&D projects going on right now, DOE funded in the US, and in Europe you have projects like that. You have everywhere projects that work on, let's develop alloys that can tolerate more impurities. How much impurities can be tolerated for what application? We have R&D projects going on. I mean, look at Subodh Das with his Remade Remade Institute, where he's taking out, I think right now it's just iron and copper. But I mean, trying to pull out some of the impurities from scrap. I mean, great idea. Will we be able to make this economically viable? I don't know. I hope we can, but I mean, we're working on a lot of angles to be able to integrate more scrap and still make a product that can do the job.
Right.
So-
And what, because at the end, I think it's going to be a mixture of some of different approaches. It's not just, technology, because as you just said, technology is helping a lot, but we need to figure out how to, make this technology accurate, and that will take time. And during the time, if we just sitting there and wait, the companies will be not profitable, and the process will be slow. And with the industry moving that fast, we don't have that luxury right now. So I think it's going to be something between technology is going up and this flexibility that allowed us to introduce more contaminants, or let's say another different products into the aluminum, will merge in some point. Now, let's talk about these inclusions and how those inclusions, let's say, not support the properties of the aluminum products that you will need, and how we can interact with those different, let's say, approaches to make this happen. I mean, what I want to understand is, okay, these contaminants or these aggregations are making something into the alloy. What are they doing, and why this is a problem?
Yeah. So, and it's interesting. I'm actually working on a project where we're R&D project where we're trying to find ways to convert impurities into something useful. So something that is maybe, let's say, an oxide or a carbide. Could we convert that into like a little, like a metal matrix composite? That it is actually a constituent that adds to strength of the alloy? Or could we convert the shape? I mean, every time I have something like a needle or a plate, it's bad. We know that. But if I convert it into a small globuli, then it gets better. So we have a lot of projects like this going. At the same time, of course, we're working on improving our melt treatment technologies. As you know, I mean, ultrasonic treatments have come a long way, things like that, filtration. I mean, also detecting impurities in a fast way, because we all know POTFA has been around for I don't know how many decades, but I need 2 weeks. So if I'm continuously casting, I can take my sample and wait for 2 weeks and then say, okay, now I can release it, So it's good to adjust a process, but I need faster ways. So getting ways to get quick feedback about melt quality, and then getting better ways to treat the melt, to improve the quality, to take the inclusions out or making them harmless. I think there we're making a lot of progress, and that will definitely help.
Yeah, definitely. And what do you think about, because as far as I know, we have some like certain guidance from the Rocky Mountain Institute talking about, and I want to get into this scrap world right now, right? Because we already know that primary smelters have certain amount of CO2 per ton that they are producing, right? Depending on the technology is going to vary, but we have it there. And it's clear. But on the secondary side, it's a little bit complicated. It's like blurry, because you don't understand very well. Everyone is saying, it's post-consumer scrap, 0 CO2. Yes. And I think it's not like that. It's not that easy, right?
Well, on post-consumer scrap, we currently all agree. And I mean, the argument is always that, okay, if I save something from landfill, then it should be reset to 0, because, well, the alternative would have been I lose it completely. Now,
exactly.
So if I say, well, the wheel that I took off a scrap vehicle would have gone to landfill, really? Who would throw a wheel into a landfill? You could argue like that, but on the other hand, well, we need the incentive as well to recycle at the end of life, and I think that's why it's important that anything end of life should be reset to 0. I'm an advocate of that, but on the pre-consumer side, there we have to be careful, because I mean, the Rocky Mountain Institute has published really great study and everything, and the problem I see is, if we had a perfect world, always a complete life cycle and everything everything analyzed, perfect. Then
Right.
I can calculate whatever way. I will always capture everything, but I never have that. I always take a very small partial view of it. So as you know, there is what we call the cutoff method. And well, that's what the Rocky Mountain Institute suggests as well. AEC picked that up for calculating. And I said, well, that's dangerous. The cutoff method says that, okay, if I need, let's say, 10 pounds of aluminum to make this part, and the part is only 6 pounds, so 4 pounds of aluminum goes to waste.
Right.
Okay, so these 4 pounds end up somewhere, whether it's a scrapyard or a scrap dealer, or it just goes to a remelter. Well, if the remelter gets it, okay, how much carbon footprint does it have? Well, cutoff method says that, okay, all the 10 pounds that went into the 6 pound, the whole carbon footprint should go into the 6 pounds, and the 4 pounds of scrap should be 0. So if I don't know differently, I assume that my 4 pounds of pre-consumer industrial scrap has 0 carbon footprint.
Right.
And that's where I always say this is dangerous, because people will attack us and say, guys, you're just greenwashing, because the guy who made that 6 pound part only calculated the 6 pound of aluminum, because he said, well, it's like the example of the cookie, you know, when you take a big cookie dough and you punch out a cookie, well, the cookie has a certain amount of calories. Well, the dough that you throw away has actually the same amount of calories. So if you just eat the dough and say, oh, now I don't eat any calories,
Right.
well, you're cheating. Okay. So that's why.
Excellent example. Excellent example.
So that's why I say we should always use this byproduct method that says that if I use, let's say, extrusion scrap. So when I calculate for a customer the carbon footprint and they are using extrusion scrap, I just use the semi-finished aluminum number for extrusion, which whatever is 6.3 tons of CO2 per ton of aluminum, I think. And for sheet the same, and for cast the same. So if I don't have a real number, instead of using just 0, which will really lead to greenwashing, because I'm just assuming they were attributing all the carbon footprint to their product, which they definitely didn't usually, because they want to look good too.
Right.
So let's just use the average at least. That way, at least we're not greenwashing. We might not be perfect, but if I don't have a better way to be precise, at least use an average. So I always recommend using this byproduct method. That way, with scrap, I at least have a published number for industrial pre-consumer scrap. And for post-consumer, I reset to 0 at the scrapyard. Now, if they do things at the scrapyard that creates carbon footprint, I have to add that. If I bring it if my scrapyard is not on my site, but it's somewhere else, incoming logistics. And you know what? That's easily 0.1, 0.2 just on its own when we transport scrap. So that has to be added too. I can't just say, oh, well, it came to my door, you know, I still consider it 0.
Right. And I think that approach is very, very honest. When we try to define the way to improve, the way to improve that we really want to low down our carbon footprint, we need to understand all the sources. It's not just, oh yeah, it's 0, and from now on, I am totally green. Because it's not true. And if you are getting stuck in that idea, I think you will not able to go and see outside and say, hey, how I can improve whatever it is that I need to improve into my process, my logistic, or whatever, to really go and merge or reach those goals, right? So
yeah.
How do you feel that the foundries, talking about the die casters and all these guys that are making the final product, are feeling about having more recycling content into the raw material they are using? Do you think that they are very open-minded to this, or not so? I mean, how do you feel that?
It depends. It depends who you talk to. I mean, you have some, they are embracing this totally, and their only problem is that the OEMs are slowing them down, because honestly, if you deal with big OEMs, you often have a sustainability department there, and they're pushing you to, maximize recycling content and lower your carbon footprint. And then you have some guy in the quality department who basically always says, oh yeah, but I'm not allowing you to go with whatever impurity above a certain level. And if I have to integrate scrap, you know what? You need to look at the impurities. And some of them, they are there because they have always been there. You ask the people at the OEM, nobody can explain to you why you need them at that level. But okay, we've always had that, so let's keep it. Well, no, you need to have an open OEM as well that will, not talk with two different objectives here. But then the foundries I'm dealing with, a lot of them are embracing it. I mean, look at Ronal, for example, the first carbon neutral recycle wheel. Great job, excellent. I mean, a lot of foundries in the past really integrated scrap to lower the price. Now, unfortunately, we all know that just doesn't work anymore. It's not really cheaper, at least not right now, to integrate scrap, but it's the right thing to do and often mandated by the OEMs. And usually, if they are halfway open to it, because they have to change things in their process, they as well need to work with a PODFA analysis. They might have to increase degassing time, add fluxing, add another filter somewhere, do all the analysis. You have to go through a lot of qualifications again. It's a lot of work. It costs time and money. But I mean, in the end, you can also say, well, I'm doing the right thing. And a lot of people use it for marketing purposes. I mean,
definitely
using this a lot for their marketing because they want to be considered a super sustainable company.
Right. And let me ask you something, because it's really interesting what you are saying about the OEMs. At the end, for me, it's weird that they are claiming to build more green, let's say, automotive or whatever product they want. And they are saying, okay, if you want to be like my supplier, you need to provide me green material, right? Like green aluminum material. But then they said, we are not allowing you to have certain amount of aluminum scrap because of the impurities. So how hard is to deal with this? And I know you already answered this question, but my question is, it is really a huge difference between having some impurities against just having primary aluminum in a final product. Is really, that gap is huge. And I think the gap is going to be like on mechanical properties, right? At the end. It's huge.
It depends. I mean, it depends on the product, but also depends
the application,
on the application and the type of scrap. We did trials with a gigacasting alloy, and we tried that with just pure primary versus different scrap contents, and up to 80 or more % of scrap content. And well, we couldn't find a difference, but those were all clean wheels that were added. So, if I had used a bunch of mixed scrap and then tried to come up with ways to get it still into spec somehow, I would have probably seen a different result. But it all depends which type of scrap you use, and wheels are always the perfect example. It's post-consumer, but it's so clean. Integrating that is very easy and still have a very high quality product. Some other scrap where I have like stamping, thin sheet where I have a lot of surface, and then maybe compacted, but still it's very easy, possibly even contaminated with lubricants, with all sorts of things. Getting that clean is a lot more difficult than getting some clean blasted wheel shreds. So
right. Yeah, but now that you are getting to this point to talk about, let's say, more contaminants that we have in the scrap, and we can compare different type of scrap with the wheels and aluminum sheets and engine blocks and whatever. But what are those new technologies? Because we already talked about the technologies from the sorting point of view, right? Separation, segregation, that is amazing. And you can, let's say, make a huge step separating all the alloy, but then you will have another contaminants and inclusions, right? Like plastic, oil, coolant, whatever it is. What are those technologies that are, let's say, approaching into this market in the way that we really can be more accurate on cleaning processes and having a better aluminum recoveries out of the melting process. So are you seeing these technologies getting more and more involved into the aluminum industry?
Yeah, definitely. I mean, on all sides. I mean, whether it's pre-cleaning, of course, and
Right.
because recovering some of those, whether it's lubricants or whatever, can be actually very good.
Right.
Can even save you money. I mean, you know that if you recycle machining chips, you really want to get that machining fluid out before you throw them back into a
Definitely.
furnace, dry them. But I mean, delacquering becomes a much bigger challenge. But we have seen big improvements there as well, and then also in the furnace technology, that we have better furnaces, better ways to filter emissions out, dust out, whatever fumes, smoke.
Right.
So I think on all those fronts, and then on cleaning the metal, like we said before, I mean, up to ultrasonic melt treatments and things like that, that we were only dreaming about 10, 15 years ago. Now we see them actually on the market. So I think all those technologies are maturing, coming to the market, being applied now.
Right. And before we wrap up this episode, Martin, what are the challenges that you are seeing right now, the foundry industry, and not the foundry industry, the secondary cast houses are facing right now? Because the foundry industry, they just need to adapt to have more aluminum that has been manufactured with more scrap and deal with the OEMs to try to, be more flexible and allow them to go with this material and go into the green path. And let's say if we look on the primary sector, okay, they are doing some improvements there, of course, like plasma burners and all these different type of, let's say, improvements. But what do you think is going to be those big challenges that the cast houses will face in the next year?
I think the biggest challenge is that everything is changing, just everything, I mean, the market is changing. I mean, in the past, you could have a cast house just making A380 and you would fill it, and that was a great market, or a 319, or
Right.
Well, they went into engine blocks and transmission houses. So with more electrification, those products are just going away. So the market is shrinking, but we still have a lot of Zorba, Twitch that needs to go into something. So we see the mismatch. We see scrap streams changing. In the past, well, I was easily able to tap into stamping houses scrap. Well, the sheet companies don't like you at all if you do that. They want their scrap back. So, but at the same time, now we have different type of scrap, and that's the end of life vehicles. Now the F-150s with mixed car bodies, but all aluminum. We have to recycle that. It would be crazy to just throw that into a shredder and try to convert it to A380 that nobody wants anymore. So we have to find better ways, new alloys. And then at the same time, all these new technologies we talked about, secondary cast houses need to invest in all of those, need to stay up to date with it. What can I do? What do I need to do? And make all these investments. So it's everything's changing. The supply market, the demand side, and the technology that they need to use. So you need another challenge?
Right. No, not really. And let me ask you a final question, because I was thinking about this question, but I forgot to ask it during the episode, is how easy is to recycle the new trends of EVs that we are seeing out there? Because you talk about the giga casting machine building a huge structure, right? Because right now, I will say that it's not easy, but it's kind of easy to recycle the cars we have right now. It's just parts, right? But right now we will have like the battery structure, the body structure, and everything is one alloy, but it's a huge piece. So how easy is to recycle this type of, let's say, product?
Well, it's definitely not easy. I mean, currently, if you ask a recycler if they can get a knuckle or a control arm out of the car, which really should not be too hard, they will say, no, I don't do that.
Right.
I take the wheel off, and I take the catalytic converter off and maybe a few other things. But yeah, I'm not touching the body. But I mean, that's the whole point, Now we have the single alloy huge piece that's like 100 pounds or more. Well, it's worth it to get it out. So
Oh yeah,
will we
definitely.
get the car wreckers now to go in with saws or with, I don't know, other instruments, or do we design the car body in a way that I can more easily actually detach those giga castings? I think we have to, because otherwise they're all pretty clean alloys too. They're basically like the wheels. So you want to be able to recycle them or upcycle them, not downcycle them. Would be really a complete waste to downcycle them into something like A380. So
Right.
we need to find better ways to disassemble the car body in a much smarter way in the future.
Right. Well, there's the another challenge that we add just to
Oh,
the
yeah.
global challenge. Right? So Martin, thank you so much for being here with us. It's always a pleasure to talk to you.
Sure.
And have all this huge information just make my brain blow. Where the people can find you if they need some consultant or anything from your side, because I really want the people to understand that they can reach out to you and use your knowledge to improve what they are doing right now.
Well, you can find me on LinkedIn. You could also find my website at viami.ca, because I'm in Canada. Or they can just call you and you give them my coordinates. So
that would be easy. Okay, Martin, thank you so much for your time. Really appreciate it. Say hi to
sure.
your daughter, and I really
Yeah.
appreciate the effort on the article. It was an amazing article, and hopefully it's just the first one that we will, make for
Yeah.
the industry. And again, thank you so much for your time, and please keep giving the input that you are giving to the industry, because I think it's helping a lot.
Dirty Scrap Podcast.